WMPG thrives with support from listeners and from Maine Solar Solutions. Maine Solar Solutions, helping empower homeowners and businesses with solar electric solutions for 9 years. Information at mainsolarsolutions.com.
You're listening to WMPG 90.9 Gorham, Portland, Southern Maine Community Radio from USM. Live from the Orion Cygnus arm of the Milky Way galaxy, this is Scientifically Speaking, a weekly half-hour program devoted to elegant curiosities, and I am one of your hosts, Sarah Chang, and joining me, as always, is Bernie Rhyme, DJ Star Watcher. How are you, Bernie?
Yes, hi, Sarah. Very good. Thank you.
Bernie's our professor of the Astronomy Lab here at USM and our local protector of the night skies. Reach out to us at WMPGScientificallySpeaking@gmail.com or on Twitter at WMPGSciSpeak. And you can head over to WMPG.org to find the last 5 weeks of archives of all of your favorite shows, including this one. Bernie, could you let our listeners know what's up in the night sky for this coming week?
Yes, certainly. I'm glad you asked. Okay, so this will be Friday, June 24th, and this is the very best day for that great alignment that we've been in the process of for a couple of weeks already. This is very rare, of course, once in a lifetime. So if you haven't already seen it, try to see it. You only get like 3 or 4 more days, but it's best on the 24th because it'll be all crowded within just over 90 degrees of the sky. Then it'll spread out, and eventually Saturn is going to be rising well before midnight, and it won't be up anymore by the time the sun comes up. So the setup is not only are they all in the morning sky within like just over 90 degrees, they're in order. So your first one up, well, first one in order would be Mercury. Of course, that would be the last one to rise before the sun. So like 4:30 would probably be the latest time you could see this. So you got Mercury, then the brightest one is Venus. Then you have a gap. Then you have Mars and Jupiter pretty close together. And then you have a gap, and then you have Saturn. So if we reverse it, of course, Saturn comes up first before midnight. Then Jupiter and Mars are almost together because they're starting to spread out now. And then Venus comes up about 4, Mercury at 4:30, and the sun comes up about 5. So definitely make sure you look for that. The days are still pretty long, even though we're just a couple days past summer. That, of course, started on the 21st at 5:14 in the morning. So they were like 15 and a half hours long. So we've only lost a minute or two in the last 3 days. So that's not too much time there. The moon is going to be a waning crescent. It was full back a few days before. And so the moon comes up at 2 in the morning. And the good thing about the moon now is it's going to start to point out all the planets in that sequence.
Oh,
So
nice.
it was by Saturn a few days ago, and it's going to be by Jupiter. And I have this all written out here in the column, so I'll give you the details. And the other neat thing about the 5 planets, you can actually see all 7, but Uranus and Neptune are also in that mix, but you need a telescope to see those too. And they're not in sequence, of course, because then they'd have to be out beyond Saturn, and they don't come up that early. Okay, so actually the moon.
Can I just ask?
Oh, sure, go ahead.
Can we see Neptune and Uranus with the observatory telescopes?
Oh yeah, well, I was just out there last night with a 16-inch Meade. Oh, we saw amazing things. We saw, all the usual, like the different clusters, and the Lagoon Nebula, and the Ring Nebula, and the Dumbbell, and all those. But Andromeda hasn't quite come up yet, so we didn't look at Andromeda and the Perseus cluster. But oh yeah, definitely, you don't need a telescope that big to see him, but you can't just see him by looking at him.
Yeah.
Okay, so the 24th of tonight, if it's clear, the moon will be less than a tenth of a degree close to Uranus, and potentially, if you have a good pair of binoculars, you could see that. That's as close as that's going to get. And then June 26th, the moon, which is still waning crescent, it's going to pass 3 degrees north of Venus that morning. And then June 27th, the moon will pass 4 degrees north of Mercury. So they're staying in sequence. And then we're going to get new moon on June 28th. And after that, this whole show is basically going to be over because it starts spreading out, and then Saturn rises too early to still be up. And then Mercury is only up for a few weeks every month anyways, and that's going to sink back down. So you definitely have to get out there and look at that and try to get some pictures. You might not be able to get all of them. So far, I've actually only seen 4. I have a couple trees. I haven't seen Mercury, but I'm definitely going to make some efforts to see all 5. And maybe not Uranus and Neptune, but at least the 5 that we can see. Good. So that's basically it. It's a very interesting week coming up.
Awesome. Yeah. Thanks, Bernie.
Oh, you're welcome.
So when is the last day that people can see all of them?
I think Mercury would drop out by definitely the end of June. So that new moon is June 28th. So I'd say after June 28th, you get like 4 more days to see it.
Okay.
That'll be pretty
Okay.
much it.
All right. But then we can still see at least the others.
Oh yeah, the others will still be morning, and Saturn becomes an evening planet, and then Mercury disappears and becomes an evening planet like 2 weeks later or something.
All right.
So it'll still be nice. They'll be
Yep.
mostly in the morning, but not
Yep.
just as perfect as they were now.
Yep. So get out there
Yep.
early morning
Yep.
and
We don't
check
have
out
to
those
stay up.
planets.
We
Yeah.
just get up and look for them.
Tips from yours truly. Well, thank you, Bernie.
Yeah, you're welcome.
And if you couldn't take notes fast enough, you can also check out the monthly What's Up column in the Portland Press Herald. So last time we talked about some of the diamonds that potentially might be raining on Saturn. And then we talked about Enceladus, right?
Yeah, we talked about Enceladus. Don't you remember?
Oh, no, because you were talking about Titan, and I was like, wait.
No, we said we didn't get
Oh, yeah. No, I was yeah. So we
Enceladus.
forgot Titan last time, but we ran out of time anyway. So
Right,
sometimes
right,
things go
right.
just wrong
Yes,
enough.
Yes.
Let's talk Titan.
So we're talking about water cycles or something cycle, precipitation.
Hydrologic-Like.
Yes, I liked your word. Hydrologic-like cycles on all of our neighboring planets. And last time we talked about Enceladus, which is one of Saturn's moons. And let's move on to Saturn's largest moon. What happens on Titan?
Well,
It's not like Vegas. What happens on Titan?
Yeah, no, we can share that. We can share that.
actually, what happens on Titan does not stay on Titan. Titan is losing its methane, and so it probably will only have a methane cycle for the next couple tens of millions of years, and then
Only.
yeah, and then
Oh,
it'll
that's
just
pretty
have
short.
these like stream beds and river beds, just like Mars. And
That's
if
crazy.
alien scientists come in here, 1 billion years down the road, they'll be like, there must have been some fluid there, but we don't know what. Let's send rovers for decades and just keep guessing. So on Titan, it's cold enough that they've got this methane thing going, right? And
Yeah.
so it is probably the most Earth-like of all of these cycles that we've been discussing, in that the methane exists in stable form in lakes and rivers and seas on the moon, and it evaporates as turns into a gas, and it goes up, and then it condenses and it precipitates and it falls back down as rain. We sent a probe down there. ESA sent a probe down there, Huygens, back in, what was that, 2005, I think, and it landed in mud.
Oh.
Yeah,
It
on
was
a dry
just
lake.
incredibly cold mud.
So
Yep.
is that like methane mud?
Yes.
Yep, and ethane too. There's also liquid ethane there, which is C2H6 instead of CH4.
Mm-hmm.
So, interesting hydrocarbon.
Is there methane fog?
Yep, there was foggy.
Presumably.
The view wasn't great at all. Yep.
Yeah. Well, I mean, there's
Good view.
clouds. We know that there's methane clouds because no one had ever seen the surface of Titan before, because the clouds are so dense, almost like Venus.
Ah.
So yeah, all that has to do is if the clouds get down to the ground, fog. But I don't know if that happens, but it could, I bet.
Yeah.
That's so cool.
Right?
Yeah.
So because I think of methane as a greenhouse gas.
Mm.
Is Titan hot or cold?
It is very cold.
It's cold because it's so far from this. It's 259 degrees below zero.
Hmm.
But it's the only moon with an atmosphere, a really thick atmosphere.
Mm.
So, yeah.
Yeah. So the rocks on Titan are made of water, because when we have ice, right, your ice is slippery, right? That's because the outermost layer of molecules of the ice is in phase change, and so it's slippery. But on Titan, it's cold enough that you would actually have to stand in place for a little while to start slipping, because the heat from your body would come out and like warm up the feet of your spacesuit, and then it would warm up the rocks. So eventually you'd start kind of like sinking into permafrost, like in Alaska or something. but they're just rocks at that point.
That's
at those temperatures.
so fascinating.
Hmm.
Yeah.
I mean, technically, our rocks also can become molten
Yeah, lava.
Right.
Silica.
And so then there's the
Yeah.
whole question of like, is water just lava?
Water.
Depends on who you ask.
Yeah.
Huh.
Hmm.
Is water lava? That should be the show name.
Mm-hmm.
Is water lava, comma,
Mhm.
man?
The next step. Humans from water.
Yeah.
So it rains methane on Titan.
Yes.
Yep. And
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 just
there's
as
rivers
Earth
and lakes
has
and
a
streams.
just as Earth has a water cycle, Titan has a methane cycle.
Yes.
Yep.
Probably
cool.
the most similar thing.
Yeah. Yeah.
Yeah.
And Titan has like deserts.
Probably.
Hmm.
Yeah. I mean, if it had
Like
a
water
sea on one
deserts?
side and then some land and a mountain range and then nothing on the other side,
Yeah.
Hmm.
That's so cool.
probably. Yeah.
And it probably has tides still. Like,
Oh, I bet.
yeah.
Yeah.
Tides, yeah.
Mhm.
Wow.
Mhm.
Yeah, I thought Maine had rough tides. Boy,
Yeah. 8 feet.
Titan. I bet Titan has stronger tides. Yeah.
Yeah, you were talking about who has 300
Io,
foot
300 feet
tides?
of Io.
Io,
Yeah.
yeah.
Lava tides.
Hmm.
So tides of methane and ethane. That'd be interesting, yeah.
Yeah.
That's crazy.
Yeah.
Last time we talked about when we were talking about Saturn and how Saturn potentially could have diamonds raining down. Neptune is also theorized to have raining diamonds. So Neptune is the 8th and furthest planet. I feel like I skipped Uranus because I don't know anything about Uranus, unless you guys have something on Uranus.
No, it's
We've only probed it once. What? Guys, what?
This is a very mature show. So Neptune is the 8th planet and has actually a composition similar to Uranus. So maybe this possibly applies to Uranus as well. They think it does actually. So Neptune's atmosphere, very similar to Saturn, is primarily composed of hydrogen and helium. And there are traces of hydrocarbons, which is just chains of carbons and hydrogen feet. I call them feet. I don't know. They look like feet.
They do look like little millipedes,
yeah,
kind of. Yeah.
Right. And possibly nitrogen is potentially in the atmosphere.
Mhm.
It also contains a higher proportion of ice water, ice ammonia, and ice methane. Neptune is the one that has like vertical stripes, right? When you look at it.
Yeah, it's
It's
well,
just
yeah,
like the wind, yeah. And so the weather is basically characterized by very like extreme dynamic storm systems. Winds can reach speeds of about like 600 meters per second. I don't know what that is in feet or miles, but it's very fast.
It's fast.
And there is an abundance of methane, ethane, and ethene at the equator. It's about 10 to 100 times greater than at the poles. It's like a very wide range. So it has been theorized that Neptune and Uranus actually can actually crush methane into diamonds. Very similar to Saturn, but Saturn was a little more like they had the lightning that like split the carbon.
Saturn, the hydrogens were getting energized off. But in this case, this is like how neutron stars are formed, just straight up crushing the carbons together till the hydrogens get squeezed out.
There have been lab experiments to confirm that it is possible, but you need like significant pressures to get there. And so they think it happens somewhere around 7,000 kilometers inside the planet. But yeah, it's possible. And so once they form, they think that they fall like raindrops or hailstones towards the center of the planet. I don't know if it's kind of similar to what they think happens on Saturn, that it, melts into something. I don't know how hot it is at the center, at the core of Neptune, but that's what they think. So what scientists think is that Neptune, Uranus, Saturn are not unique in potentially having diamond rain in their on planets. They actually think that there's a really good chance that other gas giants in our galaxy have similar atmospheres and may also see similar diamond rain. So, if we want diamonds, we should just send all the evil diamond miners out to space and go collect diamonds out there. Might be a little more, higher chance of collecting them.
Yeah, it's crazy to imagine what that process would be like, because 7,000 feet deep into the Earth, you're actually about 7,000 miles. You're actually about 1,000 miles from the other side. Like you're basically through at that point, right? But on Neptune,
Earth
Uranus,
is
7,000 miles down. That's like, okay, you're a decent chunk of the way in.
Yeah.
Keep going.
But you're not on the surface, so you
No.
have to like fly. Or yeah.
You'd
It's
need,
not that dense that you would just walk on it.
Oh no! But you need some sort of weird combination of an incredibly robust airship and also submarine.
Mm-hmm.
Yeah, getting those diamonds would be a real challenge.
Yep. All right. I am not going to call it a planet, but our dear friend Pluto. Mm-hmm. What happens on Pluto?
Yes, it's a very dramatic place. And I've talked to several actually professional astronomers who still want it to be a full-fledged planet. Yes.
It's not
Pluto
over.
has basically a liquid and nitrogen cycle. So they discovered this July 14th of 2015 when the New Horizons mission got there. It was launched on January 19th, 2006. Took that many years to get there. So it does have a thin atmosphere. And basically, the cycle works based on the way Pluto goes around the sun. It gets as close as 30 astronomical units and as far away as 50. So it averages about 40 astronomical units from the sun. It's actually tilted at 110 degrees. So it's got a tilt. So this on a longer term, because it takes 248 years for 1 year on Pluto, on a longer term, this huge ice sheet, which is shaped like a heart, which is kind of neat, I'm sure it's a coincidence, actually melts and grows and changes, at least over that time cycle. So the left part of that heart is called Sputnik Planitia, and the right part they named after Clyde Tombaugh, who discovered Pluto in 1930, the Tombaugh Regio. And so basically, it's cold enough on Pluto to have the nitrogen always being solid. It turns solid at about 350 degrees below 0 Fahrenheit, and Pluto averages about 385 degrees below. It might warm up a little bit based on the seasons, but it's not a big difference, obviously, not on Mercury. So it's a little bit difference in temperature. But so sometimes there is some liquid nitrogen in some places, but basically it's solid nitrogen, and it changes in those cycles.
Right, so it sublimates under direct sunlight and kind of rises up off of this glacier, circulates around the planet a little bit, and then in the night kind of freezes or deposits. Right, it doesn't turn into a liquid. It just goes straight to solid and kind of snows down. And then in Plutonian winters, because Pluto's another very eccentric orbit, right? So its seasons are more about how close or far is it to the sun, more than what's its axis doing right now. So in the Plutonian winter, the entire nitrogen atmosphere, tenuous atmosphere, just freezes. It just like that's snow on Pluto is just what used to be air. It's just now you're in a total vacuum and you have some snow. Crazy.
And the sun would be awesome. 1,600 times dimmer. So it'll be just like a faint star in our sky. Because Pluto is 40 astronomical units away, and you got to square that. So 40 times 40 is 1,600. Like even on Jupiter, it's only 5 times further than the Earth, but the sun is 25 times dimmer on Jupiter and 1,600 times dimmer on Pluto. That's why it's so much colder. But that inverse square law of light is important.
Would Jupiter be the morning star?
It could be, probably,
Maybe.
Life on Pluto.
So Pluto has a nitrogen cycle. kind of a basic one. Weird thing is that there doesn't seem to be much, if any, nitrogen outside of the heart of Pluto, right? Like we know that there's glaciers and it's causing this atmosphere and this wind, but it's only in this one spot. What's up with that? We'll have to send another probe.
Yeah, well, yeah. Even the one that went by didn't land. It just went by, got a lot of good pictures, and now it's going on to other Kuiper Belt objects.
Yeah.
So we got to send something to Pluto that will land, definitely, yeah. And oh, actually, since you mentioned the moon going through our like tail and getting some rust, Charon, the biggest moon of Pluto, which is half the size, Pluto's 1,500 miles across, Charon about 750, it has red spots on it called tholin, which is basically rust from the atmosphere of Pluto that got transferred onto Charon. It has these marks, and you can see that.
No kidding.
Much more obvious than in the Moon-Earth combination. You can actually see that. That was the Charon actual connection to Pluto with these tholins, this red stuff.
That's really cool. Wow.
So that's not oxidation, right?
Yeah,
it's some other process.
Yeah, it's oxidation, but yeah.
Wow.
Yeah, but you can see it in the case. You can't see it on the moon. I guess if you go there, you could prove it, but yeah. Yeah, and then it has 4 other moons, which are smaller, but Charon is it's almost like a double planet, being half the size of Pluto. And then it has 4 smaller moons. We thought for sure we'd discover more moons with the New Horizons, but we didn't. We knew about all 5 moons based back on the Hubble Space Telescope. It found a lot of other neat things, but it didn't find any more moons. So yeah. Yep. It has ice volcanoes, all that sort of thing. We did a whole show on volcanoes.
We did a whole show on volcanoes.
We did, yes.
Like 3-4 years ago.
That also got out of control and turned into a mini series.
Yeah.
So, okay, so we hit Pluto. Let's keep going, Sarah.
Yeah, we'll keep going.
At even greater distances around other stars, there are planets.
What about the Kuiper Belt?
Oh, yeah, sorry. Come on back. Turn around.
Here, come back.
Back up a little bit.
Got ahead of myself.
Okay. Well, I mean, it's going to be similar to Pluto in a way. You have Sedna and Eris and some of those. I mean,
Quoar.
Yeah, I mean, I don't know. It's not as dramatic. I'm sure you don't have the big nitrogen glaciers, but you have basically things like that, just smaller.
Oh.
Yeah.
I felt like that was very anticlimactic for me.
Well, unless Seth can add something more about the
crazy thing. Every trans-Neptunian object has a nitrogen glacier in the shape of a human organ. Weird coincidence.
Yeah.
Really?
Yeah.
Like a different organ.
Yeah, Sedna's more like the liver, Pluto's like the heart.
It's
the liver. It's crazy. Kind of neat, but we have no proof of that.
All right. Now let's go out. Let's go out. 60.
The outer.
Yeah. Oh, go.
Outer limits.
Try it again.
The outer limits.
That was great. I'll add like a echo effect there.
Thank you.
If I can, I don't know. So 63 light years away from our solar system. I don't know at what point. Yeah. So there's a planet, an Exo Extrasolar Planet, discovered in 2005, called HD 1897333b. It's actually HD 1897333b. It's actually a little bit bigger than Jupiter, 13% more mass. It orbits its host star once every 2 days. It's called a hot Jupiter, and that means it's a class of planets that have similar characteristics to Jupiter, but have very high surface temperatures because they're like pretty close to their host stars.
You said it goes around once every 2 days around its parent star?
2.2 days.
Yep.
That's fast. That's 1 year.
Wow. That's faster than the Parker Solar Probe.
So in 2008, what's special about this planet is that in 2008, a team of astrophysicists, they detected and they were able to detect and monitor the planet's visible light. And huge success, yay. And this was further improved in 2011, so they got, better detection. And they basically found, I don't even know what this word is, the planetary albedo.
Oh yeah, it's like its reflectivity.
Yes.
Reflectivity coefficient.
Is significantly larger in blue light than in red. But the
Hmm.
blue doesn't come from like ocean or watery surface. It actually comes from hazy, kind of turbulent atmosphere that they believe is laced with silicate particles.
Hmm.
And so they think that it rains glass.
Hmm.
Ouch.
Yes.
Specifically, it rains magnesium silicate, which is, glass is made of sand, which is, silicate base. Anyways, the planet has really fast winds, temperatures of over 1,000 degrees Celsius. So the rain is like basically being blown like horizontally. And so it rains glass sideways at like 7,000 kilometers an hour.
Yeah, that could hurt.
Anyways, so it's just they think. It's not for sure. Obviously, we can't observe it yet.
Mhm.
Can we go back to the solar system?
Where do you want to go back?
I don't like it here.
um, but let's keep going. Yeah,
Okay.
no. 923 light years away from us is a very well-known planet called Ogle TR56b. OGLE. I'm just calling it Ogle. OGLE TR56b. We know very little about this planet, but it is a gas giant that is also about like 1.39 Jupiters as far as its mass. It also only takes 1.2 days to orbit its star. It's hot Jupiter.
Is this Earth days, or is it like one of those weird things where
I
it's
think it's
cheating by
Earth
rotating
days.
super slow like Mercury?
I don't know. Good,
I think it's
good
Earth Day,
question.
yeah.
I think it's Earth days though.
Yep.
It
They're,
has an. Oh God.
they might not need telescopes on their planet due to the gravitational lensing. Like what? That's got to be blazingly fast. It's got to be
Yeah.
stupidly fast.
No. Hmm.
Sorry.
Yeah. Yeah. The estimated surface temperature is about 2,000 degrees, which is apparently hot enough to form clouds made of iron atoms. So scientists think that it rains iron on this planet.
Yep.
Can we get some metal music?
Heavy metal.
Air
um,
and rain.
yeah, and similarly, scientists think that it certainly rains iron on some brown dwarfs, which their atmospheres contain, gaseous iron and silicate, da da da. And
Yeah,
so,
so brown dwarf is either like a super Jupiter or just
hmm
a
hmm
stellar remnant or something that for whatever reason
right.
it's got um, some nuclear fission going on still, but no fusion, right?
Yep. Yeah. All right, last exoplanet. 1,044 light years away is a planet called Hat P7b, or it's also called Kepler 2b. I don't know why this one has a cute nickname. Cute. Discovered in 2008, it also orbits very close to its host star. Much larger, much more massive than Jupiter. It has crazy extreme temperatures. But what they think reigns on this planet is that the clouds on the planet could be made of corundum. Have you heard of that?
What's that?
Corundum. It is a crystalline form of aluminum oxide,
Hmm.
and that is what forms rubies and sapphires.
Huh.
So they think it could rain rubies and sapphires on this planet using kind of the typical, pressure. Anyways.
Wow.
Yeah.
So that's
So
like it's the same basic substrate
yeah,
for those crystals, I guess.
yeah,
So kind of like similar to how we might get sleet or hail or
right,
snow, they might
right.
get rubies or sapphires. Is
Yeah,
just
but it might be short-lived,
right,
kind
right.
of. Yeah, yeah. So, before we go valuable stone gem mining on other planets, um, for it to rain those types of things on Earth, we would have to be really close to the sun. have crazy temperatures, have ridiculous storms. Basically, we would be really miserable and we wouldn't be able to enjoy those fine things.
Good old planet Earth where the rain doesn't hurt.
What are your guys' takeaways for our listeners?
Who was it that said that the universe isn't just stranger than we imagine, it's stranger than we can imagine?
Oh yeah, James Jeans, I think, the British astronomer and mathematician.
Yeah,
it is
that's my takeaway.
Yeah.
I love it. Seth, thank you for joining us.
Always a pleasure.
Yeah. We love having you on. You have been listening to Scientifically Speaking here on WMPG with myself, Bernie, and Seth. Stay tuned for something for the weekend with Anella and from your favorite nerds. Just a reminder to vaccinate, to mitigate, and we're already congregating, but to congregate more.